So for question 2 on page 43, as you can see, they've given us this harmful chemical safety sign, and again it's based on an equilateral triangle, which means all angles are the same and the length of all sides are the same. The altitude of the sign is 145 millimeters. Create the sign to the given measurements. So this time it's slightly different to the previous question, question 1. In question 1, they gave us the length of the sides. They didn't give us the height of the triangle. We had to work that out for ourselves, and the way we did that was came up at 60 degrees. This question, they've just given us the height, or the altitude of the triangle from the base to the apex, but they haven't given us the side length of the triangle. So we're going to have to figure that out ourselves. So what we're going to start off by doing is just drawing a baseline on our sheet, and then we're going to draw a construction line that's 145 from the base, and that will give us the height. We can then draw our center line. We know these angles are 60 degrees, so we can then work from that center line. So first thing is first, my baseline. Now what I'm going to do is come up 145 millimeters. And I'm just going to draw a light line across. Okay. Now obviously you're going to need to have sufficient space on your sheet for this drawing, so make sure you set it up ideally on the middle of a new sheet. Now the next thing I'm going to do is pick the position of my center line. That's completely up to yourself, as long as you have sufficient space on either side of that center line. Now I know the angle is 60 degrees in an equilateral triangle, so now what I'm going to do is line the 60 degree side of my set square up with this point here, which is now going to be the apex of our triangle, and I'm just going to bring a light construction line down as far as the baseline. I'm going to do the very same thing on the other side. Bring that down at 60 degrees, and now we have our construction triangle. Okay, we also have our center line, which we're going to need for the X detail in the middle. The question also tells us there's a 10 mil instep or border on this triangle, so that's what I'm going to do next. So making sure 0 is on this side of the triangle, I'm going to come in 10, same on the other side, 10, and I'm going to come up 10 from the bottom, 10. And again, we're still doing construction lines. Just going to bring those across. I know that they're still at 60 degrees, so I'm going to use my 60 degree set square to bring those up the sides. Like so. Now the last thing we do before we start drawing in our finished lines and our heavy lines is we need to create this X in the middle. Okay, so if we look at the drawing, we know that the bottom of the X is up 25 mil from the border line here. So what I need to do now is come up 25 millimeters. I'm going to start on 10 because I'm running out of room, so there's 25 millimeters. That's the bottom of the X. Now it's telling me the X is using 45 degree angles, so I'm just going to draw in two 45 degree angles, just using construction lines for now, using my 45 degree set square this time. So before we use our 60 degree set square, we're now using our 45 degree set square. Okay, so you should be left with an X like so. Now, the thickness of the X is 15 millimeters. So, from this line here, I'm going to come out 15, and from this line here, I'm also going to come out 15. And again, I'm going to join construction lines there and there. Okay, and we're almost there. And then finally, what it's telling me is that the distance from this line here down to the bottom of this section here is 25 millimeters, which means it's the same here, the same here, the same here, the same here, and the same here. It's the same all around. So on my drawing, where these intersections are, that's going to be my reference point for that 25 millimeters. So I'm going to come out 25 here, and that is going to give me the bottom of the X. Okay, now an easy way of doing this, I need this point over here so that I can bring it back up. So if I were to just line my T-square up with that point and just mark that off over here, I can then use my 45 degree set square again to bring that up there. Okay, at the top it's the same thing. I need to come out 25 millimeters, and I'm going to bring that down again at 45 degrees. We need to keep everything perpendicular. Now I know by looking at this, I'm going to need to bring these lines out slightly further. Okay, and now I can do the same thing to find this line here. I can send this line, or this point at the top, across to here. That's now my point there, and I can bring that down here at 45 degrees. So, okay, the good news is we can now start heavying in this drawing. So I'm going to start with the X. And then I'm going to switch back to my 60 degree set square for heavying in the triangle, because don't forget we're using two different set squares here. We used 45 for the X, we're using the 60 degree set square for the triangle, because in equilateral triangle always we use a 60 degree set square. So there's my baselines. Now for my 60 degree angles. And that is question 2 done.